Hi guys, this is the next section, Predictive Analytics Pipelines for NLP. Now, we move on to the first video of this section that deals with NLP analytics pipelines. As we discussed, like general-purpose machine learning, predictive analytics has a workflow. It starts with loading or ingesting data, then cleansing the data. After that, extracting features from the data. Next, training a model on the data to generate desired outcomes based on features. And finally, evaluating or predicting some outcomes based on the data. However, if we want to use text, particularly unstructured text, we must find a robust and efficient way of feature engineering to convert the text into numbers. There are many ways to do this, and we'll explore a few common ways this can be achieved. Hence, there are several stages of transformation of data possible before a model is trained and then subsequently deployed, finally doing the predictive analytics. Moreover, we should expect the refinement of the features and model attributes. We could even explore a completely different algorithm repeating the entire sequence of tasks as part of a new workflow. When you look at a line of text, you see sentences, phrases, words, nouns, verbs, punctuation, and so on, which when put together have a meaning and purpose. Humans are very good at understanding sentences, words, slang, annotations, or context extremely well. This comes from years of practice and learning how to read or write proper grammar, punctuation, exclamations, and so on. So, how can we write a TensorFlow program to try to replicate this kind of capability? Using this method has two disadvantages. NLP models often fail to interpret the semantics in a complex sentence, especially for long sentences or even words. For example, the two sentences, TensorFlow makes predictive analytics easy, and predictive analytics makes TensorFlow easy, might result in the same sentence vector having the same length equal to the size of the vocabulary that we pick. The second drawback is that the words is and TensorFlow have the same numerical index value of 1. We can imagine that the word is might be less important than the occurrence of the word TensorFlow. Therefore, we should remove these type of words from the regular text or sentences. Let's see using text analytics. Text analytics is the way to unlock the meaning from all of this unstructured text by providing means to uncover patterns and themes and derive contextual meaning and relationships. Text analytics utilizes several broad categories of techniques, such as sentiment analysis, which is analyzing the political opinions of people on Facebook, Twitter, and other social media, is a good example of sentiment analysis. Next is topic modeling, which is a useful technique to detect the topics or themes in a corpus of documents. Latent Dirichlet allocation is a popular clustering model using unsupervised algorithms. Next one is term frequency, inverse document frequency. TF-IDF measures how frequently words appear in documents and the relative frequency across the set of documents. The information could be used in building classifiers and predictive models. Next one is named entity recognition. Named entity recognition detects the usage of words and nouns in sentences to extract information about persons, organizations, locations, and so on. Last one is event extraction. Event extraction expands on named entity recognition NE2, establishing relationships between the entities detected. This could be used to make inferences on the relationship between two entities.